Okay, so this is going to be my first lesson on chapter 4. It might be review for some of you, but it's basically just solving two-step equations. And this idea or this process is going to be important for the chapter as a whole and for the course as a whole, and ultimately for whatever you do in Math 10. This is kind of like learning the ABCs, or maybe like rules of grammar when you are first learning how to write with the English language. Here, when you're learning how to write and manipulate the English language. Here, what we're learning how to do is to read and write and manipulate logic in mathematics. And this is sort of the foundation of that. Specifically, this is all to do with algebra. All right, so by the end of this lesson, you should feel comfortable modeling problems with linear equations involving two operations. Again, an operation is something like adding, or subtracting, or multiplying, or dividing. Those are the four most basic operations. And then using multiple strategies to solve linear equations with rational numbers. So we are including fractions here. We're including fractions. Fractions will never truly go away. So using multiple strategies to solve linear equations with rational numbers, again, using two operations. So in our warm-up, we practiced, well, we didn't really have a warm-up. We'll just do our best through these notes. So let's just pretend. Yeah, in our warm-up, we practiced solving one-step equations. For each equation, there was one thing that we needed to do: addition, subtraction, multiplication, or division, in order to solve. I imagine that says in order to solve for the variable. In two-step equations, we will need to complete two operations in order to solve for the variable. So what we'll need to do here is, and this is our set of instructions that we can always refer back to if we ever get stuck. What we need to do is always remove the constant first using addition or subtraction. So I'll do a little example on the side. 9x, let's say minus 3 equals 2. So let's apply this first rule here. I'll call this the first rule. So let's apply this first rule. We need to remove the constant first on the side of the equation with the variable. So first we have to understand what the constant is. So where's the constant along with the variable here? Well, this is definitely not a constant. That is a term with a variable, so that is definitely not the constant. That 9x is not the constant there. Well, negative 3, that is a constant, and 2, we have a constant here as well. So which of these two constants are we going to get rid of? Well, the constant that we're going to get rid of is this one. We're going to get rid of this constant because it is the constant. It is the constant with the variable term. So this first step, in a sneaky way, might actually be a little bit confusing or ambiguous, because you might say, okay, I have to always remove the constant first, but I have two constants here. Well, what we really mean by this is remove the constant that you could say is crowding. Remove the constant that you could say is crowding the variable term, right? The constant that's next to it. So we'll remove that first. How do we remove this constant? Well, we either add or subtract. How do you get rid of negative 3? Well, you should add 3. So my operation that I'm going to perform here is adding 3 onto the left side of the equation. But we know in balancing equations that if we have to add something to one side, we have to add that exact same thing to the other side in order to keep the equation balanced. So let's rewrite our equation with the changes that we've instituted. So 9x minus 3, and then I'm going to write plus 3, equals 2 plus 3. And you don't have to show this step that I'm currently writing. I'm really only showing this step because it might have been a while since you've done this. So then we can start to simplify gathering like terms, right? So negative 3 plus 3 is really just 0. And then 2 plus 3 will evaluate to 5. What do we have left on our left-hand side? Well, we just have 9x. You will eventually do this kind of operation so fast. It took me a while to go through it and to explain it, but you will eventually do this kind of operation so fast that you will be able to do things like this in your head with enough practice. So that's the first step. The second step, after we remove the constant, the second step is to remove any coefficients or divisors using multiplication or division. So again, we can look at our variable term here. Here's our variable term, and this is the coefficient of our variable term. And what we need to do is remove any coefficients or divisors using multiplication or division. So how do we remove this coefficient of 9? Well, we have to think about what this coefficient of 9 is doing to x. This 9 is being multiplied against x. So how can we get rid of that? To get rid of this, to get rid of multiplication, we do the opposite. To get rid of multiplication, writing tiny there, to get rid of multiplication, we divide. I'm writing all this down simply to erase it because I'm going to need to show you my work here. So this 9 we're going to get rid of. This 9 is being multiplied against the x, so we are going to divide it out. And whatever we do to one side, again, we do to the whole other side. So this 9 divided by 9 on the left side, that evaluates to just 1. So now we have a coefficient of, let me get my red back. Now we have a coefficient of 1 in front of our x term. We can write that coefficient explicitly as 1, or we can just say x, because 1 times x is just x. And then we just have 5 over 9 on the right-hand side. And that would be our solution, right? That would be our answer. Another way of saying this is if the value of x in this particular equation, if the value of x that we substitute in here is 5 over 9, then this equation represents a true statement. We could test that, right? We could try plugging 5 over 9 into this equation. And if we try plugging 5 over 9 into this equation, let's actually try that below. 9, I'm just going to rewrite. I'm going to rewrite this whole equation here, but I'm going to substitute the solution that we found just to verify whether it's true or not. So I'm going to plug in our solution of 5 over 9 in for x. Right? Originally, in this equation, we would write x by the 9, but here we have a particular number that we're substituting in, which is 5 over 9. So instead of writing 9x, we write 9 times 5 over 9. And then we follow the instructions of the equation, right? So we do multiplication of 9 by 5 over 9, and then we subtract 3, and then we see if that's equal to the right-hand side. So let's look at what happens when we take 9 and multiply it by 5 over 9. Well, 9 is really fraction, 9 over 1, and we see that we can cross-reduce here, right? We have a factor of 9 on our numerator here and a factor of 9 on our denominator here, and those can simply divide out to 1 or cancel. All that we have left is 5. And 5 minus 3 is 2, and 2 is definitely equal to 2, so we know that this particular solution works. Right? This particular value of x will make this equation true. So we can say the solution is verified. All right, so I'll more quickly work through some of these examples. So let's look more closely at some of these examples in these boxes here. Here we have 3x minus 4 equals 11. Now, the first step is always to get rid of the constant, and we might again see here that there are two constants. So what we can do is we can identify the constant that is next to our variable term, right? This is the constant, this -4 is the constant that is next to our variable term. So what I'm going to do is I'm simply going to rewrite this equation, 3x minus 4 equals 11, and I am going to get rid of that constant. How do I get rid of a -4? Well, I add 4, and I do that to both sides. I do it to both sides to balance the equation. Then I can rewrite my more simplified equation. Well, 3x minus 4 plus 4 is really just 3x. That's all that's left. And 11 plus 4 here is 15. Right? 11 plus 4 is really just 15. So that's the first step. The second step is to take our equation, and this is really the same equation as what we started with. They are equivalent statements. It's just they look different, but they're equally as true. And we can take this sort of simplified equation, and we can get rid of the coefficient. So what's the coefficient here? The coefficient is the number in front of our variable. So here I have 3 times x equals 15. How do you get rid of that multiplication? Well, you divide it out. So 3 times x, I want to get rid of that 3. So I want to get rid of that multiplication by 3, so I divide it. I divide it out. 3 divided by 3 is 1, and we can see here on the left-hand side I'm just left with x, but we have to remember that whatever we do to one side, we always do to the other as well. And then we can simplify. So on my left-hand side, I just have x. On my right-hand side, I have 15 over 3, which is actually a nice number. It's just 5. And that would be our solution, which we could verify. We could verify by plugging 5 in for x into the original equation and seeing if the left side is equal to the right side. Well, 3 times 5 is 15, minus 4 is 11. We can see that this would be a verified solution. This would be a true solution. All right, so